Bien. Well, hello everyone again. Good night for Spain. Now I am going to talk about the evidence of presence of rock varnishing and extreme acidic environment in Rio Tinto system. This is a part of my thesis coordinated by my supervisors Ricardo Amils and Felipe Gómez in Centro de Astrobiología en Madrid y en el Centro de Biología Molecular Severo Ochoa, en la Universidad Autónoma de Madrid. Well, very quickly, what is a rock varnish? Rock varnish is a type of rock coating, and rock coating, by definition, is any type of deposition on a bedrock. Could be carbonate crust, aluminum glaze, or maybe lithobions on a rock. In the case of rock varnish, are composed mainly by clay minerals cemented by iron and manganese oxides. And the rock varnish surface have a strong influence of lithosphere, biosphere, hydrosphere, and atmosphere. We can classify the rock varnish in 5 types. For us, the most interesting type is the last because the environment that appear this type of rock cutting are in river splash zones. The main characteristics of this type of rock varnish with respect to other rock varnish, especially in desert environments, are the low quantities of barium and manganese in comparative with the desert varnishes. And on the other hand, we have our system study, Tinto River. Tinto River is located in the middle of the Iberian Pyrite Belt, and is a natural extreme acidic environment whose origin is the microbial activity under the Iberian Pyrite Belt, and for its characteristics, for example, low pH or high quantity of heavy metals present in solution in the water, especially iron. In fact, the iron, for this reason, Tinto River is red, is considered a good geochemical and mineralogical Mars analogue. Okay, we sampled some rocks in different points in Tinto River system. In this talk, I am going to talk with a specific rock located in Berrocal zone. It's very important in this point to comment that the extraordinary difficulty to extract the enough quantity of material for apply different techniques. Because the crust is very well cemented in the bedrock. In fact, we obtained 3 samples from the rock: the external part, the internal part, and the mix of material as a product of trying to separate this brownish crust. We applied different techniques, X-ray diffraction to determine the mineral composition, the mineralogy, sorry, ICP mass in order to obtain the values of elements present in our rock crust, quantitative PCR in order to confirm our DNA extraction is effect node for sequencing. Illumina, we applied Illumina MySeq sequencing, and also we applied microscopical techniques. For one hand, the Carfish technique in order to confirm our sequencing results, and on the other hand, scanning electron microscopy in order to observe the general structure of our rock cutting. Well, also, we recollected small pebbles and sediments around the sample in order to compare these samples with our larger sample in our rock cutting to observe if there is any type of enrichment in our interesting samples. Okay, the X-ray diffraction reveals in pebbles and sediments the typical mineralogy found in Tinto River system: quartz, of course, hematite, and jarosite. In the case of our rock cutting, also we found quartz, but also we found islite. For one hand, islite. Islite is a type of clay mineral present in a lot of rock varnishes, and also we found clinochlorofirroan is have the clinochlorofirroan have an intermediate oxidation state, and in its crystalline structure have iron 2 and iron 3. with for this reason is intermediate oxidation, and also is found in some rock varnishes. In the case of values and quotient of elements, we found interesting similarities with some rock varnishes in literature. In the case of manganese, the value of manganese, we found a little bit more quantity of manganese in our rock quatting, specifically in the external rock quatting, and specifically more height with respect to sediments and pebbles. Okay, it's not a lot of height enrichment in manganese, but it's very important to remark that we are working in an extreme acidic environment with a lot of heavy metals, especially iron. And in fact, if we compare the manganese values with lead values, we can see that in sediments and pebbles, we have a lot of quantity of lead, but in the case of the external rock quatting, we have a lot of less quantity, but more quantity than the internal rock bedrock. This reflects that in our external rock, we have a little bit enrichment in some elements. In the case of quotas of elements, in the case of aluminum nickel, in sediments was not possible to determine this quotient because the quantity of nickel was undetectable. In the case of pebbles, the quantity of aluminum with respect to nickel is a lot of height. And in the case of on rock quatting, we found a little bit enrichment in aluminum with respect to nickel, but it's not a lot of height than pebbles. And these values are typically in rock varnishes. In the case of manganese barium quotient, we can see a lot of height enrichment in manganese with respect to barium in our rock quatting. And this is very important for rock varnishes. Has typical values with respect to desert varnishes. In the case of sediments and pebbles, in fact, the quantity of manganese is too low in comparison with the barium. This reflects also that our rock quatting have a different chemical characteristics with respect to the samples surrounded. In the case of sequencing, the Illumina results reveals an extraordinary biodiversity in our rock quatting. We can see a lot of firmicutes, of course, actinobacteria, bacteroidetes, archaea, and other minor members, also protobacteria, microorganisms, with members capable to oxidize, reduce iron, and especially manganese. In fact, we found that in beta protobacteria some reads of Ramlibacter, recently reported in manganese coccult types. And the Carfish technique confirms our sequencing results. In the case of scanning electron microscopy, in general terms, we found a typical structure for iron oxides, a botryoidal structure, but it's very difficult. But we found some particles with a different texture, with a lot of enrichment in manganese, and also associated with peaks of carbon. This reveals interesting chemistry in the surface of our rock quatting. For conclude this talk, X-ray diffraction analysis reveals the presence of typical minerals found in rock varnishes. Okay, the enrichment in manganese is not very high, but it's important to remark that by SEM we found manganese-enriched precipitates. The 16S biodiversity reveals the presence of typical microorganisms in rock varnish, Acinetobacter, Caulobacter, or Arthrobacter, capable to oxidize manganese, and also members capable to oxidize iron, very typical found in Tinto River system. Examples are Acidotibacillus ferroxidans, Acidoborax, or Leptospirillum ferroxidans. The beta protobacteria readings of Ramlibacter have been detected in manganese oxidation coccult type, recently reported in Nature this year. And to resume all this, the chemical, mineralogical, and microscopical observations indicate that our rock quatting sample is a genuine rock varnish, a rock varnish influenced by the river, a rock varnish type 5, and is the first rock varnish described in an extreme acidic environment. For its characteristics, rock varnish in Tinto River system can be an excellent Martian analog in each to study in future years. Thank you so much for your attention y bueno, si tenéis alguna pregunta.
Gracias. Bueno, tenemos una pregunta. La pregunta ¿es un bien material al tener planes para los componentes?
¿El qué, perdona? Que no sé si te he oído bien. ¿Puedes repetir la pregunta, por favor?
¿Es un bien material al tener planes para los componentes?
Un bien material para tener... Es que no acabo de entender bien la pregunta. No sé si pueden reformular la pregunta, por favor.
Ok. Bueno, en inglés. Is it a material good by has planes for the components?
Ok, bueno, la muestra de roca, a ver, es bastante particular, ¿vale? En el sistema de Río Tinto, porque uno esperaría que simplemente encontrar hierro y nada más. Sin embargo, el encontrar estas deposiciones de manganeso, y aunque sean en poca cantidad, con un pequeño enriquecimiento con respecto a las muestras de alrededor y también la posibilidad de encontrar microorganismos y los picos de carbono observados en el microscopio electrónico, creo que nos hace pensar de que estamos no solo ante un barniz de roca genuino, sino también que está fuertemente influenciado también no solo por las condiciones ambientales, obviamente, sino por la actividad microbiológica que se está sucediendo ahí en la superficie. Y obviamente influenciada por el río, por las deposiciones que tiene el río sobre la superficie de esta roca.
Bueno, mira, la pregunta la acabaron de corregir y ¿es un bien material el tener plantas para los componentes?
Plantas para los componentes. Es que en el caso de plantas no tiene mucho significado porque en la zona alrededor no hay vegetación. Es decir, las condiciones, porque está además, las muestras están tan cerca del cauce del río, están en lo que es el lecho, que no crecen ahí plantas. Las únicas que pueden crecer están un poquito más alejadas de lo que es el cauce del río, donde puede tener las avenidas, las crecidas, y son desde luego plantas muy resistentes a metales pesados, pero ahí en esas en las zonas donde recopilamos las muestras no crecen plantas. No sé si he contestado a la pregunta de la compañera.
Sí, ya contestaron. Bueno, gracias José por tu tiempo, por
Nada,
tu
vosotros.
acción, por tu proyecto. Muchas gracias.
Muchas gracias y un placer. Venga.
Listo. Bueno, seguimos